This is the tutorial for Chapter 9, Section 6, titled The Quadratic Formula and the Discriminant. So we're spending 2 days on this section, and so this is the first day. So what we learned last week is that the quadratic formula is derived from completing the square. And the quadratic formula goes this way. It gives us our x values by just plugging in numbers. And again, the values, I start with negative b, plus or minus the square root of b squared minus 4ac all over, big fraction bar, over every single part there, over 2a. So again, these values come from the standard form of a quadratic, ax squared plus bx, and then plus c equals 0. So you're setting the expression equal to 0, then taking the values of a, b, and c and substituting them into this formula. So let's pull off the values that we have. We have a is 7, we have b is positive 8, and we have c is positive 1. So we go ahead and plug those numbers into our formula. It looks like this: negative 8 plus or minus the square root of 8 squared minus 4 times a, which is 7, times c, which is 1. And it's all over 2 times by 7. So we do some work. Negative 8 plus or minus the square root of 64. Now, we have one negative sign, so that means we're going to subtract. So you either add or subtract underneath the radical sign. And if you have one or an odd number of negatives, then you subtract. Even number of negatives will make a positive, so you end up adding. So in this case, I'll end up subtracting. And it's all over 14. So that's negative 8 plus or minus the square root. Now, I subtract these two numbers, and this gives me 36. And when I go ahead and divide it by 14, I'll end up coming up with rational equation or rational solutions, because the square root of 36 ends up being 6. So I have negative 8 plus or minus 6 over 14. And so I set up the two problems. One of the problems goes this way: negative 8 plus 6 over 14, which ends up being negative 2 over 14, which makes the negative 1/7. The other solution is negative 8 take away 6 all over 14. Well, that's negative 14 over 14, which makes negative 1. And so those are my two solutions. So let's take a look at another problem where we have to do a little bit more work on it, because we have to isolate or get everything over, set it equal to 0. And in this case, I'm going to end up adding the 98 to both sides. And so if this were a factoring problem, I'd take out the common factor. But since we're using the quadratic formula, it's not so bad. We can just use the numbers that are given to me. And so I've got my a term here is 2. B is negative 28, and C ends up being positive 98. And so I substitute those numbers into the quadratic formula. It looks like this. So instead of x, in this case it's going to be w, and same thing over here, this should have been c, but I'll just leave it the way it is. So it's going to be the opposite of b, so this will become a positive 28. So if b is negative, then when you plug it in the formula, it becomes the opposite of a negative, which makes a plus positive. And then still plus or minus the square root of negative 28 squared. So whether you square a 28 or a negative 28, you still get the same number. And then minus 4 times a, which is 2, times c, which is positive 98. And this is all over 2 times by 2. So numbers are a little bit bigger here. So I'll probably use a calculator in order to come up with the squaring of 28. So all I'm going to do is 28 squared, and that gives me a value of 784. And then minus 4 times 2, which is 8, and then times by 98, and that gives me 784. And so I get the same number underneath the radical sign, and it's all over 4. And so when I do that work, here we have just one solution, because the 784 minus 784 makes 0. And 28 plus or minus the square root of 0, well, square root of 0 is just 0, so you don't even have that anymore. So you just have it over 4. You can see how you're just getting one solution in this case. Positive 7 is the answer. So we have two different types of answers. Here we had a parabola that crossed the, we'll call it the x-axis in this case. Cross the x-axis in two spots. Crossed it at -1 and -1/7. These two values right here, those are where it crosses the x-axis, -1, -1/7. In this case, it only crossed it at one spot. So the vertex, try to get a little straighter line there, the vertex is right at +7. So there's 7 right there, and it just touches that and bounces back up. So we have those different types of solutions. Sometimes if we have a negative number underneath the radical, then we'll have no solutions, or at least no real solutions. But we won't see that today, so let's move on. And it says this time we're supposed to use the quadratic formula, solve, and round to the nearest hundredth. So first step is to move the 1 over. You always have to set it equal to 0. 5x squared plus 3x minus 1 equals 0. This was a 3x here. And so I'm substituting the numbers in. A is 5, B is 3, C is -1. So x is going to be opposite of b, -3, plus or minus the square root of 3 squared minus 4 times a, which is 5, times c. This time I've got a -1 all over 2 times by 5. So you can see how the two negative signs are going to make it positive. So this is where you end up adding underneath the radical sign. So -3 plus or minus 9 plus 20, because again the two negative signs make a positive, all over 10. So you see how I'm getting a number that's not a perfect square. So I'll need to set up this problem in a calculator. And so when I do this, typically what I'm going to do is I'm going to use the fraction button right here, press that, and then start entering in my numbers. So I'll move this off to the side here so I can see what my values are going to end up being. And I'll go ahead and plug those values in. So again, my values are, I'm going to plug into this -3 plus or minus the square root of 29 over 10. So I'll go ahead and put those numbers in there, -3, and then I'll do plus, and then the square root symbol, and then 29, and then I have to press the replay button just to the right, and then I can get down into the denominator and press 10, and equals, and it shows me the exact form. So then I press SD, and that tells me that it ends up being 23 hundredths, but then this 8 is going to end up rounding this up. So I'm going to write 24 hundredths because I'm supposed to round to the hundredths place. So 0.24 is going to end up being the hundredths place. Let's take a look at the next one though. So now I'm going to take that answer and I'm going to type in the other solution I get, -3 minus the square root of 29, and then I'll toggle to the right and then go down. And actually I didn't write this as a fraction, so I'm going to do it a little different here. I'm going to draw parentheses around this, and this way I make sure I do this work first since I didn't get it set up in the fraction form initially. And so I'll go ahead and go down now and divide this by 10. And then that gives me what I'm saying here, -3, the opposite of 3, plus or minus the square root of 29 over 10, and then I'll press the SD button, and it gives me -0.83. And I'm going to end up rounding this up to -0.84, and 84 hundredths. And so I'll write that number in there, -0.84. And then those are my two solutions. So let's take a look at the next type of problem that we'll end up seeing, and it talks about a basketball is passed through the air. The height of the ball in feet after the distance d in feet the ball has traveled horizontally is given by this equation. How far horizontally from the player passing the ball will the ball land on the ground? This tells us right here what h should be. H will end up being 0 because we're going to treat the ground at 0 feet. So now we know, and we go ahead and substitute in. We got -d squared plus 10d plus 5. So our a value ends up being -1. Our b value is 10, and our c value is 5. So we substitute into the formula. This time we're solving for d, so I'll write d this time instead of x, equals -b, so the opposite of b is -10, plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is negative 1, times c, which is positive 5. And it's all over 2 times by negative 1. So we work a little more, negative 10 plus or minus the square root. This makes 100, and the two negative signs cancel each other out to make a positive 20. And this is all over negative 2. So negative 10 plus or minus the square root of 120 over negative 2. So we want to try to come up with just the positive answer here. And there might end up being two answers, so let's go ahead and come up with both of them and see what they look like. So I'll go ahead and plug in the negative 10, so I'll start with the fraction button this time, negative 10, and then plus the square root of 120, and this is all over negative 2. And I go ahead and enter that, and it gives me a simplified form, and it must mean that the square root of 20 has a perfect square in it. And it sure enough does, and we were able to do some reducing, and that's what we got. It had 4 in it. And so I'll go ahead and press the SD button, and it gives me this, negative 0.475, or 0.47, and I'm going to go ahead and change around that to negative 0.48. But this answer is extraneous. Extraneous because we do not have negative time that we're going to be dealing with here. And so we're going to end up saying that this is one that we're not going to consider as a possible solution. So let's take a look at the next one. And that one, we ended up using the plus sign here, so we're going to go ahead and go with the minus sign. So we're going to do negative 10, and then we're going to do minus the square root of 120, and then we have a negative 2. We press equals, and now we'll go ahead and press the SD button, and we end up getting, 10.45. And so what that means is 10.5 seconds is going to end up being the time it takes the ball to land on the ground. So the person threw it pretty far. 10.5 seconds is quite some time for that ball to be passed and to hit the ground. But that's what we ended up coming up with the equation that they gave us. So those are the types of problems that you're going to see on today's assignment. Good luck.